resistor, cables, LED. We got our breadboard, which is a mini breadboard. Notice the LED, it has two sides, a long side and a short side. You have the anode and the cathode. The long side is the positive side. The short side is the negative side. So make notice of this when you're inserting this in your circuits, because the current only travels one way. Okay, so we are using our LEDs, and remember that the position of the LED matters. The resistor, you can connect it any way that you please, it doesn't matter. So we're going to connect this resistor to the positive end of the LED. Alright, and as I said before, it doesn't matter how you turn it. So we're going to use this cable with the positive end, and then we're going to connect a black wire to the negative end of the LED. And why we use a resistor is because we don't want the LED to be damaged in the process. So I'm just looking if everything is okay. Yes, everything is connected good. So Arduino. So we are going to connect the positive end to pin 13. This looks like pin 13. And now the ground, but I'm not sure that this is pin 13. So let's see. Is it 8, 9, 10, 11, 12, 13? Yes. And ground with a black wire. Done. It's yours. So next thing that we're going to do, we're going to connect the cable to the computer, to the Arduino first. Now let's go. Look at this carefully because the code is their brain box. We're going to define a variable, red LED, as an integer and let it equal to 13. That 13 is the pin on the Arduino. We're going to define our setup function and our loop function, which is mandatory within the Arduino interface, or IDE. So we're going to say pin mode, red LED, and then set this to an output pin. We want the output pin to be which is red LED to be an output. Then in the loop, digital write, red LED, and let this equal to high. High meaning that it is on. We want it to turn on at this point. And then we're going to insert a delay of 1,000 milliseconds, which is 1 second. Digital write, red LED, and then we're going to set this to low. So low meaning turning it off. We're going to insert another delay, which is 1,000 milliseconds, which is 1 second. And that's it, we're done. Let's review this. So we set pin mode, red LED, to be an output pin. We want to use this as an output. In the loop, we say digital write, red LED, we turn that pin on. We wait for a second, then turn that pin off, then wait another second before we do the whole loop over and over again. The variable, red LED, we didn't have to use this variable. We could just use a literal variable. We could use a literal. Say here, we could say 13. Anywhere red LED is, we could substitute that for 13, which is a literal. But I like to use variables, and if you're a coder, you will have to use variables. It makes things better. Now let's run it and see what happens to the Arduino and the red LED. Boom. Yeah, so we got our on and off functionality of the red LED. So let's go back to the code and see if we can change this 1 second blinking to like half a second. So we're going to change the 1000 milliseconds to 500 milliseconds and then on and off. Now let's see what's the implication. Yes, it's definitely faster, but I want to turn that speed up. So we're going to change that to rather that 500 to 250 on and off time, and let's see, boom. Yes, so it's definitely faster. All right, so let's make this a delay of 100 milliseconds on and 100 milliseconds off, and let's see the implications. Nice. So